Okay, we're still in chapter 2, and these are the problems. For example, I have a circuit like this, and I want to calculate the current. The voltage here is 6 volt, and the resistance is 10K. Then we can simply find the current. The voltage, 6 volt, dropped in both diode and resistor. The voltage across the diode is 0.7 volt. Then this one is 6. It is. Okay. Here. So we have 6 volt here and 0.7 volt here. Across this diode. Then the remaining here will be 5.3, or 6 minus 0.7. You divide it by R. This will give you the current. R is 10K. That's it. Very simple. For the second one, this resistor here is 3.3. Okay. And this one is 4.7. Okay. Okay, and I want to calculate the current. Both diodes here are forward biased. And this one here will have a 0.7 volt, and this one has a 0.7 volt. Then in this case, the current I equal what? I equal the total voltage, which is 12 volt. The voltage here is 12 volt. This 12 volt minus 0.7 and 0.7. Okay, you have 12 volt dropped over 4 elements, 2 resistors and 2 diodes. So the voltage across the 2 resistors will be 12 volt minus the voltage across the first diode and for voltage across the second diode, then it will be 12 minus 0.7 and 0.7. Here it is, divided by the total resistance here, which is 3.3 and 4.7, which is 8K. So 8K is the total resistance, 4.7 plus 3.3. Okay, so this is the current. And of course, if you want to calculate the voltage, use Ohm's law. This is very simple. So how do you calculate this voltage here? The voltage across the 4.7 is this current times 4.7, and this current times 3.3 will give you the voltage across the 3.3K. For this one is light emitting diode, and we need to calculate if the voltage is 5 volt. This voltage is 5 volt. And this one here is 2.1. The light emitting diode has a 2.1 volt forward bias. 2.1. Of course, if you have 5 volt here, then the voltage across the resistor will be 5.1. 5 minus 2.1. That's 2.9 volt. Then the current will be 2.9 divided by the resistance, and the resistance is 330 ohm. Then you can calculate the current. 5 minus 2.1 divided by 330. For this example, you have 2 diodes. Of course, this one here is 15 volt. Okay. Of course, D1 is forward bias. This one is forward bias, and this one is reverse bias. D1 is forward, so it is almost short circuit, or the voltage here is 0.7 volt. So this one is 0.7 volt, and this one is open. Why it's open? Because it is reverse. So this is similar to the example which I solved before. So this one as if doesn't exist. Okay. Then in this case, what is the current here? The current will be 15 minus, the current will continue. This I will continue in the resistor because you don't have diode. It's open circuit. Okay. So current equal what? Equal 15 minus 0.7, which is dropped over D1, divided by R1 and R2. R1 plus R2. R1 plus R2, 8.2 plus 3.29. Then you can calculate the current. Okay, if you want to calculate the voltage, of course, according over R1, you just multiply I times R1. This will give you the voltage across R1, and I times R2 will give you the voltage across R2 and the voltage across the second diode. Voltage across the second diode, because they are parallel. So D1, D2, I mean, and R2 are parallel to each other. Then the voltage across them will be the same. Here we have a Zener diode. This Zener diode and the reverse voltage is 3.3. That's why you see here that this is a reverse mode. So it is usually the Zener diode, we use it in the reverse mode. The voltage is 8 volt, so this is 8 volt. Okay, 8 volt for sure is more than 3.3. So in this case, the voltage across the Zener will be 3.3. If the E is less than 3.3, the Zener will be open circuit. Then if this is 8, this 3.3, then the voltage across the resistor will be 8 minus 3.3. This is the voltage across the resistor. And if you want to calculate the current, if you have a need to calculate the current like this, for example, here, okay, in the resistor, then the current will be 4.7 divided by the resistance, which is 10K. Very simple. Next one, I believe that maybe this is the last one. We need to find the value of resistance. We don't need R. We don't know R. If the current here, the current is 10 milli. Okay, the voltage is 5 volt. We know that the voltage here is 0.7 volt because this is forward bias. Okay, then the voltage across this one here is what? The voltage is 5 minus 0.7. So this is the voltage across the resistor. And if you use Ohm's law to calculate the resistance, VIR, I know the current, I know the voltage. The voltage is 5 minus 0.7. The current is 10 milliampere. Then you can calculate the resistance, which will be this number. Next one is just homework. So here is similar to the problems that I just solved, but here we have a Zener diode. Zener diode. So the Zener diode here, and it is in the reverse mode because this is 15 volt, okay, and it is in the reverse mode because it is negative. And the negative is connected to the positive. So here for sure this one will be 5.1 volt, positive, negative. Okay, so I know that this node here, if this one is a ground, for example, okay, so in this case, the voltage here is 5.1 volt. Then you can calculate the voltage across the 8.2. How? If this voltage here is 5.1 voltage, okay, and I know that the voltage across this diode is 0.7, it is given here, okay, then the voltage here is what? Of course, this is positive, negative. Then this one, if this is 5.1, then this one is supposed to be 5.8. Okay, because 5.8 minus 5.1 is 0.7. So now we can calculate the current, I. What's the current? The voltage is 15. So the current is 15 minus 5.8 divided by 8.2K. This is the current in this resistor, and so on. And of course, you continue this direction and so on. So this, if you want to calculate the voltage and current in the circuit below. Okay. So see you in the next chapter. Thank you for watching. And if you have any question, let me know in the live lecture. Thank you very much.